Hi, everybody. So, part of the work that we were doing on Thursday involved discussing how our understanding of truth definitions will help us make sense of inference rules. More specifically, what we did was we took a sentence, it was something like A is a large tat, and we began to talk about how we can, by way of our understanding of the truth definitions for our connectives, as well as the concept of a tautological consequence, we began to make inferences from this sentence. Unfortunately, somehow I thought I hit record, but I didn't record our session. So my apologies. And so what I'm doing here is trying to offer you a reconstruction of that part of our meeting. And I hope that I can be, that I will have covered everything by the time we're done. So basically what we're doing right now is we are making a transition from chapters 3 and 4 to chapter 6. So remember that we use a truth table to, among other things, determine whether or not a sentence is a tautological or truth table consequence of another or other sentences. So we can show that in a truth table. Now what we're doing in Fitch is we are going to demonstrate, that is, we're going to derive the conclusion of a valid argument by way of our understanding of the truth definitions for negation, conjunction, and disjunction. So we know that a sentence is true. Sorry, let me rephrase that. We know that a conjunction sentence is true when each of the conjuncts is true. So here we have the sentence as a premise, and I'll go ahead and make sure that we can see, I hope, as clearly as possible what this sentence says. I'm going to show our step numbers, right? So here we have the premise, A is a large tet. We know that we have a premise because it's not only got the number 1 and there's no other animal in this window, but also there is a Fitch bar, right? So remember, when you have a set of premises, whatever appears after that Fitch bar is an inference. Okay, so if the sentence A is a large tet is true, it follows that A is large. So what we do is we cite the sentence from which we've drawn the inference at number 2, and then we're going to justify the move with a rule, and this rule is based on our truth definitions for conjunction. So what we've done is we've dismantled the conjunction, and the rule name is Disjunction Elimination. We'll look at the formal structure of the rules in a little bit, but here we're sort of learning by doing, and I'm trying to leverage your existing understanding so that you can say to yourself, yeah, I get this as we're moving forward. Okay, so A is large is true. What else do we know? Well, we know that a disjunction is true in one of 3 ways. Provided that one of the disjuncts is true, the disjunction itself is true. So, if the sentence A is large is true, it follows that A is large or A is medium. Right? So I can introduce from a true sentence the disjunction, precisely because as long as A is large is a true sentence, the disjunction that I've created at line 3 is true. Notice what I've done here. I have introduced a disjunction. I'm going to go back now to sentence 1, and I'm going to dismantle the other side of the conjunction. You don't have to do this, but we'll see as we go forward that when you know what your goal is, what your conclusion is, you are going to assemble and disassemble sentences based on what it is that you're after. So I'm going to, in this case, because I want to and I can, dismantle the right side of the conjunction. I'm going to eliminate the conjunction from line 1 again. And then I'm going to introduce another disjunction. If A is a tet is true, it follows that A is a tet or A is a dodec. Notice that whenever I make an inference, I cite the line number, or we'll see in just a moment, the line numbers from which the inference was derived, right? So we cite each step and we justify each step. So this is a very meticulous accounting of how it is that we get from the beginning to an end of a derivation. Now, the last thing I'm going to do, again, based on our understanding of the truth definitions for the conjunction, is I'm going to conjoin sentence 3 and sentence 5, right? If it's true that A is medium or large, and if it's true that A is a tet or a dodec, it follows that A is medium or large or medium, and A is a tet or a dodec. Right? So 3 and 4 conjoin to give us sentence 6. So here I have introduced a conjunction. Now, one of the really nice features of Fitch is that as you go, you can check your steps. So this is the individual step checker, right? So for example, let's go all the way back up to line 2. If I want to check that I'm correct, I check the left side of the individual step checker button set. If I want to determine whether or not I've done everything correctly, I'm going to check the proof checker. Now, I haven't put anything in the goal window. We'll talk more about the way that Fitch works in some detail later, in more detail than we've done in previous meetings. But I hope that you get the idea right now that, depending on where our slider is, right, we can check an individual citation and justification, and then we can check the whole animal. Now, suppose that I, instead of writing A is large or medium, suppose that I wrote instead A is large and medium, and then I check to see if I've got this thing right. Notice I get an X, and I'm told that I have not validly applied the rule, and that's because sentence 3 is a disjunction and I've just written a conjunction, right? So you get some really good immediate feedback from Fitch on this front. Okay, so far, I hope that it makes sense to say that in the example I've given, we have dismantled and assembled conjunctions, and we've assembled disjunctions. Now, what we haven't done yet is talked about the negation and in terms of introducing and eliminating, and the elimination of the disjunction. The elimination of the negation is a pretty straightforward process. What we want to think about when we're going to talk about the introduction of a negation is a concept from way back in our thinking together, but specifically in chapter 4 to the truth table. So let me tell you a little bit about what I mean there. Okay, go ahead and take a look now at the right Fitch window. We have the following premises. A is large, medium, or small, and it's not the case that A is large. Now we know by a process of elimination that if we're told A is large, medium, or small, and then we're told it's not large, it follows that A is medium or small. We have, however, two rules that we can use to demonstrate that the inference is valid. So first, I'm going to make several assumptions. I'm going to assume that A is large, and then I'll add a couple lines, exit out of the subproof, start another subproof, assume A is medium, add a couple lines, exit out of that subproof, and then finally assume A is small. Now I'm going to scroll back up to the subproof, which is what we call an indented sequence. It's a subproof, it's an assumptive proof. Basically what we're saying at line 3 is, okay, we know what's happening at lines 1 and 2. We know what we're told. Let's make an assumption. Let's further assume, since remember, lines 1 and 2 are themselves assumptions, let's further assume that A is large. But hold on a second. We've been told at line 2 that A is not large. So what do we have? We have a contradiction. Go back to your work in chapter 4 and remember that a sentence and its negation yields a contradiction. The symbol we use for a contradiction, and in this case we're talking about a truth functional contradiction. We'll talk about other types of contradiction a little bit later. But first, lines 2 and 3 are contradictories. So what we say at line 4 is we have established a contradiction, and the rule that justifies this move is contradiction intro. Now, what do we know from this contradiction? Well, here's the short answer about what we know, and we're going to want to talk more about this because it might not feel intuitive to you, but the short story is, from a contradiction, anything follows. So in this case, since we know that sentences 2 and 3 can't both be true, then that means that A is either medium or small. And again, what I'm about to say may feel counterintuitive, but just hold on to the fact of what we're doing, and we'll talk more about what it means in a little bit. So from line 4 to 5, what we've done is eliminate the contradiction. We've resolved it. All right, so that's the end of our first subproof sequence. Why? Well, because I'm just saying so. Notice that there's no pre-given goal. I haven't told you what the goal is. Remember, what we're doing here is moving from our discussion initially of the conjunction intro and elim and disjunction intro rules now to a disjunction elim rule, as well as a contradiction intro rule. And then we'll move forward with our negation intro and elim rules. Okay, so we've introduced and eliminated a contradiction. Now we know that if A is medium, then that means that A is medium or it's small. Right? We know this rule from our previous learn by doing effort. So we've introduced a disjunction. And now exit that subproof. We go to our last subproof and we say the same thing. Okay, if A is small, then we can infer A is either medium or small. Again, the rule is disjunction intro. What we've done, we have the disjunction sequence at line 1, and then at lines 3, 6, and 8, respectively, we have assumed that we have first the leftmost disjunct, then the middle disjunct, and then the rightmost disjunct. So remember what we know about our truth definitions for the disjunction. We know that the disjunction is true in 3 ways. So when we're given a disjunction, as we have been given here at line 1, the way that we derive sentences from it is to eliminate it by way of a successive set of assumptive sequences. I don't know which one of those three ways sentence one is true. We say, okay, well, if A is large, medium, or small, what happens when we assume that A is large? We derive the sentence that we want. What happens when A is medium? We assume it, derive the sentence that we want. What happens when A is small? We assume it, derive the sentence that we want. So once we're finished with the sequence, and again, what will happen is you use the conclusion to determine in almost every case what how you're going to conclude your sequence. Then you go ahead and assert, once you've derived that sentence from each of the subproofs for the disjunction, you go ahead and assert it as your concluding sentence. Now let's talk about how we cite and justify the disjunction elimination rule. We always cite the sentence that started the successive subproof sequence. I keep using the language successive subproof sequence. More precisely, what I mean is it's a set of sequences that are always on the same line. They're always indented at the same location. So we'll see as we go forward, there can be multiply indented sequences, but your disjunction elimination rule always indents on the same line. It may be the case that you might do some work outside of the sequence before moving on to the next assumptive proof in the sequence, but it still is successive in the way that I've just mentioned. Okay, so we start with citation of the original disjunction, and then notice what happens when we click somewhere within our subproof. The whole subproof is highlighted, the whole subproof is highlighted, the whole subproof is highlighted. So disjunction elimination works in the way, in this particular instance, in the way that I just mentioned, namely, the justification of the rule is the disjunction itself and then the subproofs. So we say that we have eliminated the disjunction. Go ahead and click to see if we've done everything right, and yes, yay, we have. Now, before moving on, and also before looking at the rule form for each of these rules that we've just introduced, let's go back to our original exercise. And I wanted to show you how you can consult the rule form just by hovering over the notation in the drop-down menu. So this is actually quite helpful to us, right? So we know what conjunction introduction looks like. We know what disjunction introduction looks like. We now know what contradiction introduction looks like, the truth functional rule. We also know what the elimination of the conjunction looks like. We just saw what the elimination of the disjunction rule form is. And then we just learned the elimination of the contradiction symbol. Okay, let's go ahead now and go back into our textbook so that we can see these rules. And then I'm also going to show you the what I call a shorthand rule sheet that I give you guys. We're on page 573 of our text, and you can see now that we have covered our conjunction intro and elim rules, disjunction intro and elim rules. We're going to get to negation, introduction, and elimination in just a moment, but we also discussed our truth functional contradiction intro and elim rules. Now I keep saying truth functional contradiction and elim rules. We'll find that we can use our contradiction symbol for non-truth functional contradictions. So hold on tight and we'll take a look at that in just a moment. Here we are on our Canvas homepage, and I am scrolling down to our class resources module, and I'm hovering rather over the rules and strategies sheets link. And what you want to do is either download or open inline our inference rules sheet. And so notice that what you're seeing here, I won't scroll down too far because we haven't got to chapter 7 yet. And again, we haven't yet got to our negation, elim, and intro rules, but you can see that what I offer here is a more visually simple version of the rules we've just discussed. But I appreciate the rules as they're presented in our textbook because those are technically correct. And by technically correct, I mean, for example, it doesn't matter how many conjuncts we have. When we have a series of conjunctions, we can eliminate each of them and so forth. So obviously I haven't put that notation here. Okay, so let's go ahead now and move on to our last two rules. And I want to highlight the fact that our negation intro rule employs the contradiction, specifically the truth functional contradiction. So let's go ahead and take a look. Okay, so I hope this is a fun way for you to start thinking about what it is we do when we use the negation intro rule. First, meet Walter. He's super cute, right? So is Stewie. And then H. All three adorable puppies are here to help you learn negation intro. Remember who's who so that you can picture them as you're working through the exercise. First, the argument. Neither Walter, Stu, nor H is barking, so H isn't barking. Here's the proof. Let's assume that H is barking. If that's the case, then Stu or H is barking. And if that's the case, then Walter or Stu or H is barking. But wait a minute, that just contradicts what we already know, namely that neither one of them is barking. So our assumption must be incorrect. Let's work this in Fitch. So here is our argument. Line 1 reads as follows. It's not the case that W or S or H, where W stands for Walter barks, S stands for Stu barks, H stands for H barks. And then the conclusion is it's not the case that H barks. Remember, we're going to assume that our conclusion is false. And recall that we can, by way of our disjunction intro rule, begin to generate the sentence that we want, which is ultimately Walter or Stu or H barks. So we introduce our first disjunction, and then we introduce our second disjunction. Now, what we could do, if we wanted, was rather than introduce the disjunctions one at a time, we could introduce them in a single go, if you will. But I prefer taking each step as simplistically as possible. In other words, instead of making two moves or drawing two inferences at once, I think it's easier to grasp what we're doing when we work the inferences as incrementally as possible. So I'm going to go back to what I had originally. And you might hear Stewie snorkeling in the background. He snorkels a lot. kind of like a snore. All right, so we introduce one disjunction at a time. Now take a look at line 1. It's not the case that this set of disjunctions, and it is the case that this set of disjunctions, which is, or which generates the contradiction symbol. So remember, the contradiction symbol says that these two sentences are contradictories. So we introduce our contradiction. And the moment we introduce our contradiction, we know that the assumption that yields the contradiction is false. In other words, because it's the affirmed sentence H, we say it's not the case that H. In other words, we introduce the negation. So we'll talk in more detail about what it is that we're doing truth functionally with respect to the contradiction ending the subproof and introducing the negation. But for now, this gives us a worked idea from ordinary English into Fitch of how the rule works. So once again, you can see there it is, you can see the rule. It's on the, just to the right of the negation symbol. Okay, so now let's finish up with the negation elimination rule, which again, like the other rules, is a function of our truth definitions. Okay, here we are back in Boole, and we've got the atomic sentence A, which is either true or false, and then in our sentence pane, we have the repeated atomic sentence from our reference pane, and then we have the atomic sentence negated twice. And we'll see when we work through the determinations of the truth values for each of the negations that the values are identical to the original. Now, I recognize that the columns are not aligning. It's kind of annoying, and I don't know why, but I wasn't able to fix it. So the first set of values, F and T, right, are the negation of the atomic sentence A, and then the TF is each, or are both, the negation of the first negation. So you can see that the affirmed sentence A has the same value on the truth table as the two negations. So that's the rule, or sorry, so those are the values that generate the rule. So let's look at this in Fitch. So keep it pretty simple. Suppose I have the sentence, it's not the case that H is not barking, therefore H is barking. I eliminate the negation because the sentence H is truth functionally equivalent to, is tautologically equivalent to not H. So now we see that we have covered our rules so far, namely the Chapter 6 rules involving the conjunction, disjunction, negation, and contradiction, where the contradiction symbol is being used in terms of a truth functional, to represent a truth functional contradiction.